If a SIG only has one project, is it really worth saying both the SIG and the project name? Happy end of quarter fall 2017. This is Slim on Team Apply, working in the Rail SIG. And the main updates that I want to give for the quarter are first, the changes and improvements we made to our prototype, and second, some preliminary results from the study that we conducted. First, I want to start with a brief demo of what the inspection process using our tool Apply looks like. Suppose you're on this website, it's a very nice local copy of the Harvard University Graduate School of Design site, and you're like, hey, I think it's pretty cool how they have these images here that are stacked, overlaid one another, and I want to figure out how that's implemented. So using our tool, it's pretty straightforward to select the element that you're interested in, and then you can pull it up in our inspector, which behaves very similarly to DevTools. You can mouse over an individual node to see it on the page, and in this case, we might say, okay, so here's one inner container, and let's expand that to look at each of these individual figures. So right off the bat, there's less information appearing in the DOM inspector because we allow users to root one particular component rather than having to inspect the entire page at a time. This matches up well both with how learners conceive of discrete parts of a page and visual features, and the DOM tree representation of the elements on a page. So if you're only interested in this particular red boxed element here, it's unnecessary for you to have to keep in scope all of the other nodes that are on the page doing things you don't really care about. So let's say we are interested in what makes this particular, all of these images stack. And so right off the bat, this is a pretty large amount of information, although still not as much information as you would see in Chrome DevTools, which we'll look at in a second. The main innovation that we built is called visual regression pruning, and it allows you to click one button and have the system go through each of these properties, iteratively disabling them, and testing whether or not the change has any effect on the page, which you can see over on this other side here. Once the system is done computing all of the properties and styles for a given element, this button will change, and we'll be able to see which properties have been removed as having no effect on the page. We're still waiting. There's a large number of properties. Great. So if we look through at each of these properties, we can see that in the case of some rules, things like visibility hidden or font size 0 means that not applying means that we can disregard all of these rules. And alternatively, we can focus on just the properties that remain visible and that haven't been pruned. And so this can be used to help someone guide their search through all of the properties. And we can see here that position absolute, right 0, overflow hidden, padding bottom 110, and so on and so forth are the properties that are necessary to assign to one of these elements if we wanted to replicate the effect. And indeed, we can see that all of the other ones also have a large number of ineffective properties. Regardless of the actual percentage decrease, we found in a lot of need finding studies that even having more visually salient properties here was enough to help people recall, for example, when they had seen something like overflow hidden before. If we were to show every property at once and overload the user, they wouldn't be able to make that connection. But once we applied pruning to show only the relevant material, they were much better equipped to identify properties that were relevant and associate those properties with previous exposure they had had, whether through their own projects or tutorials or reading a Stack Overflow answer. So that was something that was very exciting. And you can show how disabling one of these properties causes the page to change, while disabling one of the pruned properties doesn't have any effect on the page. Cool. So just to provide some contrast, here's what the same thing would look like if you were trying to inspect this element in Chrome DevTools. So the first thing we can see is that it's a lot harder to identify which element you're interested in on the page because you have to see the entire page in one DOM viewer. If we start to identify individual figures like we've done here, we can see that a lot of the properties have been crossed out, and each of these crossed out properties represents something that was pruned by our system. But if we reload the page to take away all of the changes that Ply made, and we inspect the same element, you can see that there are way more styles that are all competing for the user's attention here. So it's not clear in this case which of these things is directly responsible for what the user wants, when in fact we saw in Ply that there were really only 5 or 6 styles that mattered here. So let's transition a little bit to talking about the motivations and research questions for the quarter. The main question we wanted to ask is, how might we leverage heuristics that correspond to learners' mental models of design tasks in order to decrease their cognitive load when inspecting a really overwhelming interface, so like this one here, identify the relevant source code that matters and will allow them to replicate the feature of interest over here, and finally, provide authentic learning experiences that lets them see what the kinds of code that professional developers would write and model those practices when they're constructing their own websites. Our need finding showed that contextual examples provide more salient reinforcement of concepts than just, say, going to the CSS Tricks Flexbox reference. It's easier for people to understand how Flexbox works when they see examples of people using it to produce effects that they find aesthetically pleasing. We've already talked about the system, the implementation. For our study so far, we have 8 users that we're using for the current data set, and we're still in the process of collecting more. And we asked people to look at the IDEO website. So here we can see that they were asked to replicate this grid element here. So basically everything in these 3 columns. And in particular, we gave them an HTML scaffold and asked them to implement first the column structure, so getting a grid with a horizontal grid with 3 columns. Second was having these images appear because there's some CSS that's used to make the images actually have heights. And third, getting the third tile here to be just visually distinct, in this case meaning it has a yellow background and it doesn't have its image showing. And so for this particular task, we had one group of users implement it using Chrome DevTools as their inspector, and one group of users implemented using Ply. And the results are pretty encouraging, even though we still only have a few of them. We see that the average time it took for a user in the Ply class to find the first milestone was 2.5 minutes, and it was 10 minutes for people using Chrome Developer Tools. And the total time was on average 17 minutes for people in the Ply class and 30 minutes for people in the DevTools class. And because our sample sizes are still kind of small for aggregate statistics to be meaningful, you can see here how the completion times for each of the milestones change across the board. So red dots indicate Ply times, and then blue crosses indicate Chrome Developer Tools times. And we controlled for both experience as well as users' stated confidence with the task. On average, users in the Ply class had both less experience with CSS and rated their confidence with the given task and time limit as lower than users in the DevTools class. Another thing we found was that we asked each user, regardless of class, to state how likely they were to use professional examples over instructional materials like tutorials or Stack Overflow when they were working on their own design projects. And although the likelihoods did not meaningfully differ between groups, we found that people who used Ply had reported that they were more likely to use professional examples after the completion of the task. And in particular, they said that Ply addressed a lot of the concerns they had over things being overwhelming or impossible to understand. And a lot of them mentioned that they even had fun or found the task relaxing, whereas those were not normally adjectives they would use to describe CSS styling challenges. So we're very excited to do some more work on subsequent quarters on further understanding what affordances we can provide based on visual heuristics to help people with sense making.